are in chapter 11, we're doing section 11.1, law of signs. Now in the very beginning of this section, pretty much all of page 442 until you get to the bottom, they're giving you a summarized version of the proof for how they came up with the law of signs. You are welcome to read it, but really we're just going to remember the law of signs and we're just going to believe them that it works. Basically they started with a triangle and used the formula for area, and then from there kind of showed that the sine of one angle over its opposite has to be the sine of the other one. So again, look at it. It starts with the area of a triangle is 1/2 base times height, and then it goes to the sines and basically moves formulas around. But what it comes up with at the end is that for a triangle ABC, basically, okay, that's the law of signs. Again, you can read page 442 if you want to see why that's true. I don't really care about proofs. None of y'all need to really know why it's true. It just is. Remember that we write the angle in capital and then the lowercase letter is the length of the side that's opposite that angle. So that means if you take the sine, let's draw a triangle. And this works whether your triangle is a right triangle or not. So we're just going to draw this one, right? We're going to say that's angle A, B, and angle C. So that's side A, side B, side C. So it's going to be the sine of this angle over the length of this side is the sine of the same as the sine of this angle over the length of this side, which is the same as the sine of this angle over the length of that side. Okay? So you're welcome to look at the proof, but this is the law of signs and this is what we have to remember. It's pretty easy to remember. It's fairly straightforward, okay? So we're going to start looking at example 1, and they want us to solve the triangle. Remember that solving the triangle just means basically find every value that's missing. That doesn't mean find the sine and the cosine and all that. Those are ratios. That means they want to know the length of every side and how big every angle is, okay? So I'm going to attempt to draw this. Now remember, we're no longer dealing with exclusively right triangles. So in this case, this one is A, B, C. They're always named clockwise. And I think all of our triangles are going to be A, B, C. And this is 38 degrees and 65 degrees. And this one is 16. Okay, so we have to find side B, side C, and angle C. Well, the easiest thing we can do, and we don't even need the law of signs to do that, is all the angles in a triangle add up to 180. So it's pretty easy to find C, right? We're going to do 65 plus 38. We're going to get 103. So then we do 180 minus 103. And we're going to get 77. So we know that that angle is 77 degrees. Now we have two sides that we have to find. Okay? We have to find side B and side C. So that means we're going to use this formula. We can probably, let me see if that's how the book does it. No. Okay, so the only one that we have all the information for is A. So let's just say sine of 38 over 16 equals sine 65 over B also equals sine of 77 over C. Now I'm going to solve those separately, but we have all the numbers. So the easiest way to do it is B sine of 38 equals 16 times sine of 65, and then we'll do the other one. Now remember, you have a calculator, but I'm using my calculator to record this, so I have to go to that table in the back of the book to look for the sines and cosines. So the first one is 38. So I need to get to 38 degrees, which if you feel like using your table, 38 degrees is on page 616. Now the sine of 38 degrees is 0.6157. And put equals here. The sine of 65 is on page, at the very bottom of page 614. The sine is, sorry, I gotta follow it along. Point 9063. Okay, so how do we solve this? We cross this out over here. We divide by 0.6157. Now, you have a calculator. I do not, so I'm just going to see what the book got. And the book got that B is equal to 23.6. Which, if you think about it, 16 times 0.9 is going to be around 16, a little bit smaller. Divided by 0.6 is going to be around 24. So there you go. You get 23.6. So that's this side. But we're still missing one value, which we already have all the equation written for over here, right? So I don't have to relook at this up. I already know that this side is going to be 0.6157b equals, and then I'm going to have 16 times, sorry, that's not b now, it's going to be c, the sine of 77. Okay, so again, I'm going to go back to the book. 77 is on page 613, middle-ish. And it says that the sine of 77 is 0.9744. Again, cross it out over here. Divide by 0.6157. Now if you look here, we have 0.9063 and we have 0.9744. Should be somewhere close, a tiny bit bigger, maybe 25-ish. You can do it on your calculator. I'm going to look at the book, and the book got 25.3. So that's the length of this side. Oops. So there you go, you solve the triangle. You have all three angles, you have all three sides. That's all you need to know. Example 2. We'll just redraw the triangle. Alright, example 2 is pretty much the same thing, except this time we have, so in the last one we had 2 angles and 1 side, this time we have 2 sides and 1 angle. And pretty much every problem should give you 3 pieces of information. They're either going to give you all 3 sides. Giving you all 3 angles is not that helpful because they're always going to add up to 180. So usually the possibilities are going to be it's going to give you 3 sides, a side, an angle, and a side, 2 sides and an angle, 2 angles, and a side. Okay? All of them should fall into there. And this one is giving us what? 2 sides and an angle. So, again, I'm going to attempt to draw that. And we start with a, oh, this one is X, Y, Z, but it's still alphabetical order. And then this one we have an angle of 61. We don't know these, but as soon as we find one of them, we can plug the other one in, right? Because they have to add up to 180. And then we have 8 and 5, okay? So, this side is opposite Z. We have both values for X, so how about we find angle Z? So it's going to be the sine of whatever angle Z is over 8 is going to equal the sine of 61 over 5. So we get 5 sine of Z equals 8 sine of 61. So I'm going to do this side first. Sine of 61, that's on page 615, close to the middle, a little bit higher up. And it says 0.8746. get rid of the 5 and divide by 5, and we're gonna get, this is 0.4, like 1.2-ish? Let's see if the book is doing it in the same order. 1.3994. That was kind of close, right? Okay, so, well, I know what the sign of z is, but that's not what they want, right? They want the actual value of z. We can go to our little table in the back of the book. And the numbers on sine kind of go up, so you just have to follow them. And let's see. 1 point, coming backwards. So, if you go to your book, you'll notice that the biggest value for sine is 1. And if you entered it in your calculator, sine of x equals 1.3994, it would say no solution, or whatever your calculator likes to say. So what does that mean? That this triangle doesn't exist. It's not possible to have those sides, the sides that we do have and the angles that we do have. Okay, so no solution. That was easy, right? Let's go to example 3, but let's see if there's any new information first. Alright, so in example 2, the side opposite the angle is too short to reach the third side. So you can look at the picture and basically, well, I already erased it. In order for that angle to work, in order for those sides to work and the angles to work, you'd have a big old gap. So it doesn't work. So even though you know 2 sides and an angle opposite of those sides, which is side-side angle, then you're not always going to be able to get the triangle. Sometimes there's going to be a solution, but sometimes they're not. It's called, so it doesn't matter, but apparently that only happens with this. Okay? So when you have 2 sides and an angle, it is possible that you'll get a triangle that doesn't work. If you have 3 sides, these are the same. Or 2 angles and a side, or what other possibilities are there? That's it. If you have those, then you know it's going to work. Also, if you have the 3 angles, it's going to work if they add up to 180. If you don't have any, but if you don't have any of the sides, you can't figure the lengths out. So if you have 3 sides or 2 angles and a side, it's always going to work. If you have 2 sides and an angle, it might work, but it might not. So you still have to try to solve it. All right, example 3. Another triangle, and they want us to solve it. Try to draw that one, let's see. Now remember, they draw it like this, and so automatically you're thinking, well, that angle is bigger than 90. Yes, it looks bigger, but unless it tells you that it's drawn to scale, you do not know. So don't make any assumptions. Okay, so I drew it opposite of them. Let's just fix it. Okay, it's gonna go like that. Kind of like that. That's a terrible drawing, but anyway. So this is P, Q, R. Again, it always goes alphabetically. Now let's see what we have. We have that this angle is 24, and we have that side is 9, this side is 12, okay? So again, we have 2 sides and an angle, but I think from the picture it works, so hopefully this one will work, but you have to keep in mind, when you have 2 sides and an angle, there's still a small possibility that it won't, okay? So we have all of the information for P, so we know we want to use that, right? So we know that the sine of 24 over 9 is going to equal, we have nothing for R. So we're not going to mess with R for now, we're going to find Q. Once we find angle Q, we can find angle R, do the rest of the math. So we know that that's going to be the sine of Q over 12. Well, we can go 12 sine of 24 equals 9 sine of Q. So the first thing we can do is figure out the sine of 24, come back to our little table here, and you got to go to the bottom of page 614. It's 0.4067. So what did we do? Take the 9 there, divide it here. Now 12 and 9 can both be divided by 3, which simplifies things a little bit, right? 4 over 3 times 0.67. So it's going to be about 1.6 divided by 3. It's going to be 0.5-ish. Let's see what the book gets. 0.5423. So what do I know? 0.5423 is the sign of Q. If I don't want the sign of Q, I want Q. So I have to go back to my table and look for signs. And you just kind of start looking. I'm trying to find 0.5425. I found 0.5422. So I think that's pretty close. And that is for 32 degrees and 50 minutes. So that's 32.50, which is pretty much 33. If you wanted to put 33, I'd be totally fine with that. So what does that do? That means we can find R. Once we have the angle R, we can find that length, okay? So how do we find R? Remember, we know that all the angles add up to 180, so we just do 24 plus 32.50 is, I'm not gonna follow rules here. I'm just gonna, because I know what this is, it's gonna be 56.50. And then you have to do 180 minus that, right? And that's 123.10. Let's see if that's what the book got. All right, for this, 147.10, yep. Nope. Yes, 123.10. Now, one other thing. You have a positive angle, and these triangles aren't necessarily right triangles, so really, this could be 32.50, or it could be one more angle, which is the complement of 32.50, so 180 minus 32.50, which is 157.10. 147.10. Let me check my math. Sorry guys, I don't have a calculator, so I gotta keep checking myself. Yes, 147.10. So it could actually be either one of those angles. Now, if it's 147.10, what you have to do is figure out if there's still a triangle that works. If 147.10 plus your other side adds up to more than 180, then it doesn't work, okay? So, if this angle actually ends up being 147.10, we have to add 24 to that, and you're going to end up with 171.10, which means that this angle would actually be 180 minus that, which is 890. Let me make sure that's what the book got. 850, sorry, that's not 100, that's 60s. Okay, so there are two possibilities for this angle, and pretty much that's always going to be the case. But you'll have to compare that angle to any other angle you have left, because if adding that angle plus your second angle is more than 180, well then that's not going to work, right? Because total they can only add up to 180. So when you actually get the sign of something, if you go in the back, my line where I found 0.5426, I think was what I found. 5422, sorry. I have that as the sign of 3210, but I also have it, if I keep going over here, nope, I don't have it in the table because the table only goes to 90, but your calculator should give you both values. Again, I haven't been using a scientific calculator, so if it doesn't, just remember that when you end up with sine of whatever angle x, y, whatever they called it, equals a certain number, chances are there's going to be two possible numbers it can be. There's going to be the one that's in the table, or the one that your calculator gives you, and there's going to be what's called the complement of that angle, or 180 minus that angle, okay? And there's a couple problems in the book where you'll have to do that, and it'll walk you through that in the book. To make sure that both angles are actually possible, add up any angles that you have. So in this case, 24 plus either 3250 or 850, sorry, either 3250 or 850, and make sure that you can still get a triangle basically, okay? So, we have that if Q is 3250, then R is 12310, which is what that triangle looks like. But remember I said don't worry about what the triangle looks like because they're not drawn to scale. Now, if Q is actually 14710, sorry, which is what I got up here, then R is going to be 850, okay? So there's two possibilities for the angle. Now, we have to figure out the side. So there's two triangles, basically, that we could have from here. And in the problems in your homework, you're going to see that. So you have to have basically two different pictures, if you want, where you can find the different values. This one looks like 24, 32, 50, 123, 10. But if this ends up being 147.10, it's actually going to be 24, and then teeny tiny angle, something like that. It's going to look like, and this will be 24, this will be 147, and what does this angle end up being? 850. Now the sides are still going to be 9 and 12, but we're going to go from either having a teeny tiny side or a big side. Let's see what those two values are. How are we going to figure it out? We have the law of sines. We have to do it 2 times. Once for this option, once for this option, okay? So, I'm going to erase all this, and we have what we calculated over here, right? Sine of 24 over 9. And we have 2 possibilities. It's either going to equal sine of 32 sine of 123.10, sorry. Opposite this. Over its side R. Or let's go ahead and write the other one, which is, let's write over here. Sine of 24 over 9 equals sine of, we're looking at this one now, okay? Because we're trying to find that side. 850 over R. So, R, sine of 24, equals 9, sine of 123.10. Here it's going to be the same with the R sine of 24, but it's going to equal 9 sine of 850. And I'm going to look both of them up in the back of the book while I'm at it. Okay, so 850 is going to be pretty early on. Second page, close to the top, and it says my sine is 0.1536. Okay, so 9 times, and we'll get to the math in a minute. Because I'm at the back of the book, I want to look up these values. 123.10 is not going to be in my table. Remember that the table only goes up to 90, so you just have to find the complement of 123.10, and it'll be the same number. Okay, so let's go back to, hopefully they give it to me, so I don't have to do the math. It says sine of 123.10. Yeah, they don't give it to you. All right, so you can try putting 123.10 into your book, into your calculator. I don't know if it's going to work. I'm going to find the complement of 123.10, which is going to be 56.50. Okay? Oh, we had already found it right there. Sine of 5650. I'm just gonna find it, okay? Because I'm running out of space. 5650 is on page 6. Nope, yeah. Page 615, close to the bottom. 6650. Sine is 0.8355. Okay, let's do this one first. Let's figure, what is the sine of 24? Did I find it out over here? Sine of 24 is 0.4067. Okay, so we just take it over here, divide it over here, 0.4067. 9 times 0.1 is going to be about 0.9 divided by 1. It's going to be 2-ish. Let's see what the book gets. But close enough, 3.4. 3.4. So if we have a teeny tiny angle, then this teeny tiny side is only 3.4 units long. If we have the bigger angle, we get 0.4067 R. We divide by 0.4067. Should be about 18-ish. 18.5. So, which is about 18.5. Which makes sense, right? Because that side looked big in that book. Okay? So, that was a lot of information. It was kind of complicated. The only thing you have to remember is when you, depending on the information that you're given, if you are given sine of something equals 0.5 or 0.3, there are 2 possible angles that can have that. There's the angle that's going to pop up on your calculator, or that's going to be in the back of the book, and there's the complement to that angle. Complement to that angle means that it's 180 minus that angle, okay? So then you're going to have to do the math for both of them. Again, when you get your 2 possibilities, you need to check to make sure that one of the possibilities doesn't make it so that the angles in your triangle add up to more than 180. Because then that's not going to be possible. You can write off that solution and get down to 1. Okay? So, a little bit complicated. There's a lot of problems on here. We can have a Zoom to talk about it, but it's really just a bunch of the same. Okay? So, exercises A, problems 1 through 6. They're going to give you either, let's see, in all of them? No, they're either going to give you, and it says right here, 3 sides, 2 sides and an angle, a side and 2 angles, an angle, a side, and an angle. So they're going to give you different things, okay? And what you have to tell them, I don't really care if you give me that information, but you have to tell me what they're giving you. So if this is the triangle and they're giving you, this angle's 30, 6, and 9. They're giving you side, angle, side. Right? Now if they give you this one, they're giving you side, side, angle. Does that make sense? So you're just kind of going through the triangle. Sorry, this would be angle, side, side, because you're going clockwise. If they give you that, then you have angle, side, angle, angle. But if they give you this side, you have angle, side, angle. Okay? So that's what you're telling them there. You're going to draw the triangle that they're giving you. Remember, it's going to be either ABC or DEF. It's always going to go in alphabetical order and clockwise direction. And you're going to tell them what they're giving you. Okay? Remember, look at what they're giving you in a clockwise order. But in all of them, they're either going to be giving you all the sides, 1 side and 2 angles, or 2 sides and 1 angle. That's the information you need to find it out, okay? Then in part B, identify the number of triangles in each case below. So those are going to be ones where you're going to end up with sine of 0.6, or sorry, sine of angle B equals 0.6. And there's going to be 2 possibilities. The traditional possibility that your calculator is going to give you that's going to come up in the back of the book, and then the complement of that, which is 180 minus that angle, okay? So in a couple of these, there's going to be more than 1 triangle. Also, remember, like we did in example 2, there might be one where there's 0 triangles that work. So you have to look at all of that. And then in 13 through 20, you have to solve the triangle. So what does that mean? You have to give me all the values that they don't give you. At the end, I need 3 sides and 3 angles. And in this one, they don't need you to tell them whether they gave you side, angle, side, or angle, angle, side. But they do need to tell you if there's any where they give you 2 sides and an angle. Okay? So if you get side, side, angle, that means that it possibly doesn't have a solution. Some of them might, but you still have to say, this is a side, side, angle, but it does have a solution. This is a side, side, angle, but it doesn't have a solution, okay? So remember, the only one that it's possible to have no solution is side, side, angle. So what does that mean? Side, side, angle, okay? If they give you a side followed by the next side followed by the angle, it is possible that it doesn't have a solution. Now, if they give you this, it's side, angle, side, right side, angle, side, and it will always have a solution. So only side, side, angle may not have a solution. Okay? So that is 11.1. Your homework is 1 through 20. You don't need the proof for any of the homework. I won't